A handful of bits here, but just, please ask questions. About. Is anybody making cabinet doors, or yeah, that's a project you're engaged in now, or you've done in the past. Have you used this set, or by any chance?
It was 5-6 years ago. So
okay, so yeah, it would have been the precursor to that. And it's really, making a cabinet door is a pretty, you do the math, and it's not all that difficult to pull off. And to that point, I'm just going to just quickly use these bits.
I'll go over and do my job.
Let me ask you something earlier about Freud making their own carbide. How long have they been doing that?
They've been doing it from the start. Freud as a company grew up out of post World War II, Italy. It was just the country was devastated, and one of the things that really took off was their woodworking business, particularly the country's woodworking business, particularly in northern Italy. And it still is a hotbed for woodworking in terms of fine furniture making, at least as it relates to fine furniture that comes from an industrial sort of environment. And it basically started out of a guy's garage, and where he was making specialty cutting tools. And very soon after, he expanded the business and got into carbide. But that's the carbide thing is just a huge thing for us, and you start to see it introduced into different areas now. For example, if you go out into the wall in our Diablo, where Peachtree has their Diablo recip blades, you'll see that we even have carbide tip recip blades, which is a pretty radical innovation. So you'll see more things with us employing carbide because we have the capacity to make it and mix it and match it to a particular type of tooling or application.
Well, the reason I was asking is I have a set of shaper plate that y'all made. Y'all ain't been lived 30 years old, and I didn't know whether y'all were using your own carbide back in those days or what.
Yeah, 30 years ago it definitely was the case that we it's our own carbide. Dave, have you been over to Italy?
Yeah.
Yeah. So
I toured the saw blade facility, the router bit facility, the carbide facility, and the specialty cutter facility.
yeah.
And it's pretty mind-blowing what they do over there. Freud makes the profile for every single router bit out of carbide shape, so that they're only really kissing it when they go to actually sharpen it for the first time. Where a lot of manufacturers weld on a square cone carbide and then grind the whole thing, which adds heat to it and it cuts down on the wear. So they're way ahead of everybody when it comes down to the quality they make, which is one of why we have such a big line out in the store. So it's pretty impressive.
Yeah, this is to Dave's point. Because we make our own carbide and we have our own molds, it allows us to come up with some really complex grinds. So this, for example, this is our top of the line general purpose blade. It's basically geared towards folks that want one blade that's going to camp out on their saw that they can cross-cut, rip, cut sheet goods with. And this blade has a 30-degree top bevel to it. So you see the severity of that top bevel. On the face of it, it's going to be hard to see, but it actually has a 4-degree shear face. So across the face of this blade it has a bevel of that's ground into it of 4 degrees, and that alternates back and forth with the top bevel. And then you have what's called a double side grind. So on the side of that tooth, you can kind of see how it's faceted. There's a primary grind and a secondary grind. And, and all these things feed into a performance is just really amazing. But the thing about this is that it's something that our competitors would have a really hard time even attempting to replicate. Because if you're buying carbide from a company like Ceratizit or Sandvik, you're getting a blank, and that blank isn't going to be necessarily all that close to the finished tooth that you're going to end up with. And a lot of the cost of producing a saw blade or router bit is in the grinding. And so with our ability to create a mold that's very close to the finished process, it helps us to minimize the grinding that we have to do, and it allows us to keep the cost down on the tooling. And that core competency is just huge for our ability to deliver awesome cutting tools at a reasonable price point. And I'll just pass that around. Be careful with this blade. Actually, it's
Sharp?
yeah, it's like concertina wire. So it's
How long have you been putting in the anti-vibration?
Yeah, that's a good question. You know what? It was before my time. So I mean, it's going to be.
But now, since a laser, it's so much
Yeah,
easier.
all of these blades, they're made out of hardened steel, and being made out of hardened steel, they need to be laser cut. Now, hardened steel helps to produce a blade that's going to be very stable and run true, and then laser cutting these things creates precision for how the seating for where we put the carbide itself, but it also allows us to cut in these what are called reeds, and they would some folks refer to them as stabilization vents or anti-vibration. There's a polymer that's infused into them, and it has the effect of minimizing the vibration on the blade. So I'm going to just grab I'm going to grab a saw stop blade that comes with the saw. And saw stop make phenomenal saws. I mean, it's an awesome machine. Their forte is not in saw blades, and typically the case is when you go out and you buy an awesome jet saw or a saw stop, they don't come with the greatest saw blades with them. You get something like this, and if I tap that, it's vibrating tremendously. Actually, more than I thought it was going to vibrate. So this is an awesome dinner bell, and if you buy a saw stop, that's how you should use this. And you should. And actually, it's still vibrating. If you touch this thing, I mean.
My saw stop blade right away.
Yeah. So. Oh yeah.
Bam!
You did that?
Twice.
Twice. What do they? Twice bitten, thrice shy? Is that what that is?
It takes me a while to get wide.
It's called pressure-treated wood.
So by comparison, it just absorbs that vibration. So it dampens out the blade. And if you have a blade that's cutting more true and more accurately, you're going to get a better cut quality. If it's not vibrating, if a blade is vibrating, it's going to wear the carbide away faster. You're going to have a lot more resistance. So it really lends itself to a precise cut. And when you go out and you look at the wall of industrial blades for industrial blades that Peachtree has, all of those blades will have that anti-vibration design. And it must be about 15 years or so that we've had that feature on the blades itself. But it's a huge difference. In some of the blades, there will be slight differences in the performance of the anti-vibration from blade to blade. The glue line rip, which is one of our best-selling blades. This is our best-selling blade overall, and the glue line rip is number 2. The glue line rip being a blade that's designed so that you can if your saw is set up properly, you can rip and you can get such a smooth edge on that you can joint it up to another board and there wouldn't be a visible glue line. That blade in particular, I mean, you could, you could have this thing hanging up like I know you guys remember Led Zeppelin. You had John Bonham, the drummer, and he had that big gong in the back. You could bang on that thing and it would there'd be no noise. It was John Bonham would not approve. So. Yeah, these the anti-vibration is definitely a huge benefit, and then you've got the PermaShield coating that's on these blades too, which likewise to the router bits, which helps to reduce the amount of heat that's produced on the blades. So very cool, and you'll notice Freud Italy. It's all these blades, the router bits. They're made over in Italy. And just an amazing facility. There's a company called Volmer. Volmer is the leading manufacturer of carbide grinding equipment in the world. They produce these really elaborate CNC grinders. You can kind of think of them almost like Wurlitzers. You can stack saw blades next to it, and it's programmed to pick them up and basically, pick it up, put it on an arbor, and accurately replicate those grinds in a wet grinding environment that puts no heat on the carbide. It's a phenomenal company, and Freud owns more Volmers than any other customer or any other company on the planet. Just hugely invested in having precise grinds with all the cutting
You were
tools.
passing it around when I.
Yeah. All right, Jimmy, be careful with that.
Are your blades and bits resharpenable?
Yes, they are.
And if they have to travel all the way back to Italy to get that replication of angles?
No, I'm sure you want. That's what you're going to tell your wife, right? I'm like, we got to go to Italy. We got to bring these blades back.
Should do a field trip on some Saturday.
No, we have a network. I'm sure, Dave. You take blades here for resharpening? Do you?
No, we don't.
You don't? Okay.
We used to. The problem was getting them from here to the sharpener and back.
Okay.
It adds so much cost to it. So
Yeah.
we just tell people where to go get it sharpened.
Yeah, we have. There's an outfit called Expert. That's in Georgia. I'm from Maine, so I'm like totally geography challenged as it relates to this area. But they're part of our Freud certified sharpening centers. We have 25 or 30 throughout the country, and these are basically sharpeners that we've vetted, that they have the capability and they're able to really properly grind this tooling. The issue with sharpening is that it's kind of like the Wild West out there. You've got a lot of sharpeners out there, and the result you're going to get back from them is all over the place. And many of you have probably experienced the situation where you've sent a blade that was dull out to be resharpened, and then you got it back and it was in worse shape than when you sent it out. So you just paid a guy to destroy your blade. And so we went with this certified sharpening setup to just to ensure that people could properly grind the blades. And if you go onto our website, you can find the contact information. And typically, these sharpening centers they'll have people that go out on a milk route and pick up blades from drop-off points, etc. So it's not necessarily that you need to truck out to a sharpener.
We do have one here in Atlanta.
Yeah.
It's on the west side of town.
Yeah.
I don't recall the name, but it is on the website.
Yeah.
That's where we generally recommend people to take the blades and bits.
Yeah.
Yeah.
Yeah, so it's so that's the way to go. If you're dealing with a guy who's got an old Foley bell saw in his basement and a stack full of lawnmower blades, and just shake his hand, bring your lawnmower blades over there, but don't take your carbide blades over there. It's it's the complexity of the grinds, but it's also as we get denser carbides that are more durable, that allow those complex grinds, that carbide has become a little bit more sensitive to heat issues. So if somebody's dry grinding carbide, they're gonna kill that blade really quickly.
Is the same thing with router bits too?
Yeah, definitely. And really, those points about using a cleaner, and you have a cleaner here, you guys. Yeah, using a cleaner to take the pitch off the bits is really really key, because when you have pitch, it's basically creating a dullness to the blade that doesn't need to be there, because you're masking that cutting edge. You're producing heat, which can help degrade the carbide or contribute to degrading the carbide. So keeping the bits clean is definitely a key thing to do. So I'm going to put some bits in here, but please, just if you have questions, just keep asking questions, because it'll take a little bit for me to swap these bits out.
Is there a 3/8 shank router?
A 3/8. In terms of diameter, there are other ones. There's like 8mm out there. You will see some 3/8 out there, but it's kind of a rare bird.
Yeah.
Mostly where I see 3/8 is with panel pilot bits. Panel pilot bits being basically, it's kind of a flush trim bit that has a drill point on the end of it, and people will use that 3/8 size as kind of the optimal size for in construction applications when they're cutting window openings. But there are different size shanks. It just tends to be that 1/4 inch and 1/2 inch are the standard in the States. All right.
Question, talked to somebody the other day about how close, if you wanted a concave and convex piece to fit together, radius, just a pure straight radius, how close do y'all get to making those fit together?
Well, they're really tight. I mean, you're dealing with plastics primarily.
Well, no, I'm thinking about wood now.
Yeah, I mean, we have different like canoe bits, for example.
On the canoe bit, is that a true 180-degree radius on those?
Yes, to my knowledge, if it's off, I mean, it's off minutely. Yeah. And there are different beading bits that can be used for that.
Does your website or any of your technical information address this about the specific radius of a, let's say, of a core box bit versus a beading bit to create a match set?
Not with a core box, because the core box are typically rounded with a flat. I'd have to check the catalog, but I don't believe that it does. But if it's rounded, I mean, in my experience with the projects that I've done, they've always been, a true consistent radius and not elliptical, or so. But that's. What is it that you're thinking about producing?
We had a gentleman in last week to talk about building chairs, the sample loop chairs,
Yeah.
and he used a roundover bit and a rabbiting bit that could be mated to create a mating joint in the arm of the chair.
Okay.
Such that the diameter of the rabbiting bit, what it cuts, versus the diameter or radius of the roundover, created a match set and basically a glue line joint.
So he reground the rabbiting?
No. But I've seen this before about, it's expensive to do this in trial and error.
Yeah.
To buy a bit and say, well, that bit's kind of egg-shaped or it's not round and not the specific diameter. It would be really helpful to have a manufacturer who has a website that will tell you these bits can be mated.
Yeah.
Yeah, his teacher had recommended a particular match set
Yeah.
from a particular manufacturer.
Well, let's talk about it. I mean, I can always, if the information isn't readily available, I can always find it for you guys. I could check with our new products designer. And
But that's not a unique problem in terms of finding bits that make sense.
I just had something in mind for several years now that I'd like to try, but it would involve probably, I'm just gonna guess right off my top of my head, probably $350 to $400 worth of router bits. And they won't
Sounds
buy
awesome.
me. You know, but if it didn't match.
Yeah. Yeah, you know, I'll leave you guys with my contact information, and you can always you can always contact me, and I can try to help you out and find out what exactly it is that you're looking for. Usually, when we have these events, we'll hand out catalogs, but it just happens that at this point we've run out of catalogs. We're coming out with a new one. So, you know, in the next 3 or 4 months, when you come into Peachtree, I'm sure they'll have a stack of these things, and definitely take one. I'm not sure how elaborate they're going to be with the information on some of the bits, but
You need a screwdriver? Yeah, it should be in the top right drawer.
Top right
In the
drawer.
actually, I think we're good with the opening. Yeah. Well, maybe not. Maybe a little bit. Maybe a hair over. All right. So, really, when you're setting up a door, it's pretty simple. You know, I'm going to cut the cope first, and whenever you're cutting doors, I mean, you just want to pay mind. You're trying to balance out the profile on the front to the profile on the back, and you want the back to at least be an 1/8 inch or so, an 1/8 inch heavy on the. And when I say the back, being the shoulder of the stub tenon that you're producing, or the full tenon in the situation. Because of the more scant that shoulder is, the more scant this piece is going to be. And if that's thin and flimsy, it's going to have a tendency to break over time. So you want to make sure that that the bit is set up so that it's going to route in at least an 1/8 inch for that shoulder on the back side of the tenon. So I've set this bit up. And got my straight edge here, and like with the previous, like when I ran the quadricut bit, I'm basically just setting it up so that the bearing is tangent to the fence, so it's right in line with the fence itself. Locking it down. And earlier I mentioned the RPMs that you're going to set a bit. And when we framed it up, when we talked about it, we said, well, we kind of based it on the diameter. So an inch, and the chart that you have on the back of these packages lays it out like such, so that, for example, an inch diameter bit is going to run, you know, max RPM 24,000 RPMs. 1 1/4 max would be 18,000 RPMs, and so on and so forth. But it's not just a. But keep in mind that's for the max RPMs. And when you have a taller bit, when you've got more mass, those are other things that are going to factor into running the bit at a slower speed. So the more steel that you're spinning around, the weightier the bit is, the lower the RPMs in which you're going to run the router. So I'm going to set this up, and I'm going to be cutting the copes for this door, and I'm making assumptions on the squareness of this, but ideally you'd want to cut this square.
I want to check check and see if that valve's, like you said,
What's that?
you were gonna check and see if that valve in here. I didn't-
Yeah, we're good.
Okay, thanks.
Thanks. And we'll move this through. Let's see. Actually, is there a square in here for?
See it's square.
Okay.
And that's how I'll push it.
All right.
Well, you're paid. I'm gauge might tell him something.
You know what? I'll be good. This will be fine. All right. So we're locking this down. You want to check with your Hans to make sure that everything's.
I'm only this side.
Yeah.
I'm only the electrical.
You're the electrician that's worse the. So hey, will you plug us in there?
Plug us in, you ready for me?
I'm ready for you, brother.
And you plugged in.
All right. So we ran the cope. We've got at least 1/8 of an inch in the back here to on the shoulder. And when I run this through, I like to just use a block that's at 90 degrees. And I'm being assumptive that this is at 90 degrees, but it's pretty darn close. And when you do that, you know, you're supporting your material. Definitely when you're routing cross grain, it's got a greater propensity to sort of to lose its stability and get pushed back. There's more resistance as the cutter cuts through the end grain. The nice thing about using a block like this is that it produces that profile in the push block, so that when I go to set up the profiling bit that's going to create the bevel, that's going to create the backing strip, that's going to create the bevel, I can basically use this as a reference, as a guide for setting up that bit, so I know exactly where the profile needs to hit, or where the bit needs to be set. So I'm going to have Hans unplug the router. I'm going to remove the bit.
You ever run it through for the second time?
No, I don't. It gave a decent enough cut that it doesn't need to be run. And it actually brings up a good point, running through this for the second time, because a lot of times people they'll route through and they'll get aggressive with it, and then they'll be left with like these little ridges or whatnot, because maybe there was some vibration because they were trying to remove a lot of stock. And on that second pass, they're just knocking those little ridges down, those little bumps down. You really want to try to avoid that situation. You always, when you're routing, you always want to be removing some stock, a healthy amount of stock, because when you're cutting, that cutting process is is crucial for the bit to be able to get rid of heat. A lot of the heat from the cutting action is carried off in the dust that's created. So, you know, when you route through and you put your hand into the sawdust or the router dust that was just created, you'll feel the warmth there. If you're just knocking those ridges down, you're just creating really fine dust. You're not creating enough to create a heat sink to carry that heat off the cutting edge. So that heat gets built up onto the router bit itself. And over time, it can contribute to the carbide degrading or breaking apart, depending on how often you do that. So it's a better scenario if you think you're going to need to make 2 cuts or 3 cuts, to set it up so that you're taking, you know, a healthy bit with each cut that you make. So we've got to take this bit out. I'm going to feel a sense of accomplishment just by not having this thing jump out on me.
So far, so good.
So far, so good, man.
It only does it once.
Yeah? All right. So we're taking the bit out. And then there's the mating bit. Which is this guy here, right? So this is going to produce that beveled profile. This set is called a shaker set, and it's got a very simple bevel on the front side. And then you've got the grooving portion of the bit for where you trap the panel or the glass or whatever it may be that you're going to insert into the door frame. So I'm going to drop this in. Again, you want to have it in at 80% or so. And you can always look on the bit itself and reference a minimum insertion point on the bit, which will give you an indication of where you need to, how you need to set this into the collet.
That one does have the design in it?
What's that?
That one does not have the design in that lower bit?
Design.
They design you the ridges that you're cutting.
Oh, it has.
They're straight there.
Well, this one has a bevel to it. It mates with the profile that I produced on the other one. Got it locked down. And don't forget to lower it. Where's my, there we go. Thanks. Good guy to have around. So, that's why you keep him. He's handy. Handy? I don't know. So, we're going to lock this down. Lock the insert plate down, and basically, you know, whenever you're routing these doors, any of these sets, you're going to have the profile to the face side of the door is always going to be down, and you're going to do that with your push block, which you just used, and you're going to set that up, and basically use that to line up with the cutter.
You have to go on the other side because you adjust.
Yeah, I got the adjustment here that maybe I can open it up a little bit more for you to. So I want to line this up. So I'm lowering it into position. And really I want to go off that top. They didn't joke around when they said it was a micro adjustment. So we're bringing it down, And you can often just go by feel here. You can kind of just run your finger across and see how it lines up there. And you want it so that top of that cutter is just flush with the tenon that you produced.
Is there a particular one of those four you're using? One of those four cutters that you're using on it?
Yeah, there's two you want to use, and there's two you don't want to use. Basically, as they are stacked slot cutters effectively. You have one cutter that's going to be recessed and lower, and then you're going to have another cutter that's higher. So I'm using one of the higher ones here as a reference. If I was referencing off of the bottom of this, then I would use the lower slot cutter. So we're referencing it, and it feels pretty good. And we are going to go through the process again of lining this up. Take our straight edge out. You know, and you can just needs to be a straight piece of wood that's straight. It doesn't need to be fancy. You don't necessarily have to have some $100 Starrett gauge or something, but just a reference to make sure that the bearing is tangent, that it's in line with the fence. And then we spin this thing around, and we know we've got free motion for the bit, so that it's not being interfered with. And we clear the table, and we get our piece of wood that we're going to use. Some folks use push sticks or whatnot. Whatever you're comfortable with. Obviously, you want to keep your hands free of the cutter. This might sound gross, but maybe you want to spit on your hands a little bit so you have some good friction to the piece of wood as you're passing it through. Yeah, so we're going to run this through.
Ready?
Yes, sir.
Ready.
Actually, I skipped a step by accident. Usually I'll take this block and I'll feed it in first. And if it's set up properly, that grooving portion of the bit that I referenced will come in and basically route out and eliminate this little stub tenon that was on the push block. That'll tell me that it's in alignment. So I've got a little bit of a hair there, like a 64th of an inch. And that's kind of references that that's how much I'm off by. And you can just tweak it on the router to get it in alignment. Oftentimes with your push block, it's nice to route a good bit down the length of it, because you have all of that material to sort of test out for the location of the bit. So just an easy way of aligning the bits. Of course, I forgot that step, and I just immediately went for it. And we'll see how we did. Which is pretty good. It's not bad. But no doubt, whenever you're doing joinery, it always pays to be precise in the accuracy of it, because if you're making a door frame, you've got the 4 joints on the front, and then you flip it over and you've got the 4 joints on the back. They're basically the front and back of the same joint. But if you're off, you're going to be off at those 8 points. And so there's a lot of sanding, etc., that you're going to have to take care of. I'm going to run through this, the last pass. And that's pretty straightforward process for milling out, making a door. And I'll often use this in my own opinion, when I'm making doors, I like to keep the pieces as wide as possible and then rip them down after the fact. Because if you got a situation like this, it's a lot easier to handle this stably and keep your fingers back as you feed it through. And then say, let's say I want to have these as 2-inch wide stiles. I can just go over to my table saw and set them up so that it's 2 inches, or 2 inches is a little heavy, so I have room to clean it up. But by keeping it extra wide, it's just it's safer, it's easier, it's more accurate. I think oftentimes when people are making cabinet doors, they kind of get ahead of themselves and make really narrow pieces that are before they're milled out. And it just it's more of a challenge. It's more of a challenge that way. And if you have your piece here that's cut to length, this is going to be your rail. If your rail is cut to length and it's square on both ends, and you route it through, it's just going to it's going to seat properly. By having that extra width, it makes it easier to ride it against the fence. In my own opinion, when you get into a situation when you're using a coping sled and you're dealing with the slots here, there's a lot of things that can go wrong. That slot might not be perfectly parallel to the fence, or you could have a situation where it's and if it's towed out, or if it's towed in, it's going to give you inconsistency in the location of the cope. So in my own opinion, if you can run it against the fence, you're going to get much better, much more consistent results than using a coping sled. So that's just on my suggestion with it. And then I'd just bring it over to the saw stop and set this thing up. So I'm running the long grain, and because these are the rails, I'm going to need to profile one side of each of the rails, because I'll get the 2 rails out of this board. And then at this point, it would just be to go over the table saw and rip it down. But
Very cool.
cool. Well, I want to thank you guys for coming out.
I appreciate it.
Yeah. Thank you. Thank you for your time this morning.